I would like to invite our first speaker who is going to talk about contextual logging for modern Python applications. I want to invite Tapan Avasthi on stage. And
Check. Hello everyone, good morning. So today we will be diving deep into contextual logging for modern Python applications. So before we start, just a quick show of hands, who all are working professionals and who all are students. Let's go with working professionals first. Great. And let's take a quick poll on how many of you have used any logging library other than standard logging library? Could you say which library you have used? Other than logging library, which library have you used? Logguru? Okay. Okay. So let's start. So in our today's session, we'll be touching upon a few concepts, including thread local, context was, decorators, context managers, log filters, middleware, not particularly in this order, but over the course of the discussion. Secondly, we will be diving deeper into standard logging module as well as the struct log library. And we'll actually explore and build a contextual logging support for the standard logging. Eventually, we'll conclude with a use case having fast API modern application with a support to contextual logging. So before we actually jump deeper into contextual logging, what context is actually? So context is a very lightweight runtime information, and it could be dynamic or it could be static, but throughout our discussion we'll be focusing more on the runtime information, which is more dynamic, and we'll touch upon the static information to a very surface level. Now, one quick show of hands, how many of you have been an on-call engineer in your organization? Great. So I think at least some of us would be able to relate when we say maybe at 2 a.m. on-call engineer is saying context is king. Now let's say we got an alert. It says 404 error. Can anyone actually spot what 404 is? Great. So, but it doesn't say what is not found, right? So that is the context. For, let's say, if we have a REST API endpoint and we are getting an alert 404, and if it doesn't actually say which endpoint is giving that error, then we are actually out of any hands. Like we cannot do any particular action on it. There are two issues. One is we are not able to have enough identification of the API endpoint to investigate further into the issue. Second thing is we don't have any prioritization. Prioritization is very super critical when it comes to production application monitoring and management of that. So let's say maybe the API endpoint is login URL. So it could mean that none of our users are actually able to log into the application, and it is probably a P0 for us. And maybe it is a history view API, and it is more of a read-only use case, and not many users are interested to actually see a history probably. So it is still critical, but slightly low critical than the login API, right? So context is super critical, and that is why we are talking about contextual logging today. Now, what is contextual logging? So we talked about context. Now, like it is very in layman's term, logging context is contextual logging, right? So, but to have a more detailed view, it is probably a development practice where we are logging context along with our other metadata information So context is, as we said, it is a real-time, runtime information for the code flow. And we are actually adding that context to our log lines. Now, why do we need contextual logging? So we talked about context is important, particularly in production environment when we are monitoring the application and investigating issues. We want to actually trace the request, specifically in distributed systems. There are multiple services, multiple applications running in, and they are interacting across the domain, right? So we want to investigate this particular service request was triggered by which source and what is the sync for that particular request. So we need all this information to make sense out of it. Otherwise, we cannot actually act on it. So contextual logging make our thinking more actionable, and we are able to actually take some action to prevent the situation or probably take a reactive measure to mitigate the issue. Now, it is super important because in distributed systems, a lot of information is runtime. Maybe in today's world, like we create the infrastructure on runtime, we destroy the pods and they will come up again. Their IP addresses will change. Their service name would remain same. That is static information, but a lot of other information would be dynamic, right? So that is why we need to be smart enough to actually intelligently inject the context to our log lines so that we are able to make sense out of it. And we'll dive deeper into how it is done. But at a very surface level, we can talk about two things. One is, of course, we explicitly add data to our log lines. And second is we implicitly let it happen like a magic. So uh, let's take a quick show of hands. Who wants magic? Right? So although developers want to, use logic, but we also are interested in magic. So we'll dive deeper into some magic about it. Now for contextual logging to actually be supported by our application, what we need is some building blocks to make it happen. So there are multiple libraries that support contextual logging directly, but we will actually first visit the building blocks, how we can actually think about contextual logging, create our own contextual logging support probably, and eventually we will be discussing about how some of the logging libraries are implementing this. Now, one of the building blocks which is super critical is context storage. So let's just break it down. What it is context and storage, right? So it is a storage that has the context. So in a way, for any application, what is the storage? Where do we actually store some information when we are coding? Can anyone just give a quick guess around it? So when we are writing code, what is the placeholder where we actually store something? Variables, right? And variables could be dynamic and they could also store some constant information. So that is why context storage is also linked to variables. And there could be static variables or some constants. What we are interested in is dynamic information. And for static information, we would actually incline towards using global variables. You will see a small warning sign over global variables. That is because we want to restrict their uses only to the things that are immutable in nature, which are more of a constant. For example, I talked about service name. For an application, service name probably will not change throughout its life cycle, right? Even if the pod goes down. So that is something, one of the use cases where we could use global variables for storing some immutable data. However, for other mutable data, which is decided on the runtime, we would actually incline towards using thread local variables or context variables. Now let's start with thread local. Thread local is nothing new. It is actually available across different programming language. Python, of course, supports thread local, and it supports thread local via the threading module, and it is super easy to create a thread local storage. We just invoke the threading.local method. Now, just to give a surface level information about thread local, it is actually storing some data, right? But the unique property around thread local is that every data that is local to the thread is actually available within its thread local storage. So we can imagine it in a very layman's term. We could actually think about a map. There is a single variable, but it actually holds different information. It actually depends on which thread is actually asking for that information. So there is a single variable, and if let's say thread 1 asks for the information, it will give some other information. If thread 2 asks for the information, it will give some other information specific to the thread. So it is kind of an intelligent storage, you can say. For the last, at the back, is the code visible to folks? Just a quick, is it visible? Okay. So it is fine, like the code is not the crux of the thing. Like what we are doing in this particular application, we have multiple threads in our application, and they are doing some dummy job in this particular code. For this particular code, we have, let's say, 5 threads that are being spawned, and they will be sleeping for some random amount of time. Now this random amount of time is something very unique to every thread. Thread 1 could actually sleep for 5 seconds, thread 2 for some other seconds, right? So this is exactly where the thread local storage will come into picture. If thread 1 asks this particular variable thread local data, it will give some value 5. But for other thread, it could give a different value. So that is how this particular storage is being used by the threads. If we run this particular program, we will get output something similar. It would, since these are random sleep times, the output will be different on different machines at different time. But one thing we could actually see is different threads are sleeping for different amount of time, and then they are waking up. It is very natural to say that the thread who slept for the longest would be actually waking up at the last, right? So thread 5 slept for 9 seconds probably, and it actually woke up at the last. Now let's jump into context variables. Thread local is good when we have our application using multiple threads and they want to store something. It could be any of the data that they want to store locally. But context variables is a step 2 in the process. It was implemented as part of PEP 567, and it is available since Python 3.7. Now, where does context variables come into picture is, nowadays we actually incline towards having a lot of asynchronous code depending on our use case. So it is very natural for modern applications to have a lot of async code, having coroutines, and that is where thread local might not be a good choice if we want to store context. That is because different coroutines could actually use the same thread to store information. And if that happens, if it is a immutable data, we could actually use global variables. We could switch to global variables. But if you are using thread local for different coroutines, having dynamic data, then it is, we are up for disaster. So that is where context bias is the situation we want to be in. And for implementation perspective, it is available through the Contextual module. It is also super simple. We'll see into the code, but it is as simple as creating a context-var, having some getter methods to get the storage values. Now let's take a look at a sample code that uses context variables. It is similar to the previous code. It has multiple threads. It doesn't have coroutines so far, but we are using coroutines and context pairs. So it is same. There are 5 threads running, sleeping for different amount of time, and they will be waking up. Now in this case, what we have done on line number 6 is we have defined thread local value is equal to context_var. So this is the place where we initialize. So we can see there is a single variable, and on line number 9, what we have done is thread local value dot get. That is a place where each of the threads will be placing a query. What is my value for the sleep time? So context pairs are intelligent enough. They know the context. The context, we can say, is the sleep time, but from a query perspective, if we think about it, for the variable, the context is which thread is asking the information. If it is thread 1, it will give the data corresponding to thread 1. If it is thread 2, it will give for thread 2. So that is the smartness that context pairs have. And this particular program is identical to the previous one. The only difference is we have replaced thread local storage with context pairs, and we are good to go. But what if we have coroutines? We definitely want to use context pairs. So in this example, it is a quick example where we have multiple coroutines. In this case, 5 coroutines, and each of the coroutines are responsible for handling a request. Now, as part of the code flow, what happens is different coroutines receive a different request ID, and they want to handle that particular request. In this case, the context is the request ID, and that is where we initialize on line number 6, request ID is equal to context_context_where. And on line number 9, as part of the handling the request, we have set that value, request ID dot set. Like I said, like the implementation is not super critical here. We are just using some of the getter and setter methods from the context pairs. But the real thing to look into is how it is actually being queried in a specific coroutine. Now, if we see line number 11, we are actually getting this information, and so far we haven't used logging, but we have a print statement, which is probably done locally from most of the developers, right? So we'll switch to logging pretty soon. But in essence, let's see the output of this particular example. We have request ID in current context, and we will have different request IDs as per the coroutine that was handling that particular request ID. So the conclusion is, for coroutines, we should be using context pairs. If we use local, like if we use the thread local storage for coroutines, it is more predictable to actually be corrupted. One coroutine could be actually writing on something that was written by the previous coroutine. So to summarize, of course, context bias is a winner here. It is supporting multiple threads as well as multiple coroutines in the application. However, there is a trade-off. It is not always that we want to switch to context pairs. When we actually use context pairs, there is an overhead that is involved. So if our application is actually just using multiple threads, we are good to use thread local. We should not sign up for an overhead just because it is super cool to use, right? So that is why context pairs is more critically used in modern applications having coroutines, because it is safe to use even if there are multiple threads using using some context. But in case of slightly different use case where we have a single thread, where we have multiple threads, thread local is good to use. Now comes the magic part, how we are actually doing the logging part. So let's switch our print statements with logging. And so far we are just using the standard logging module, and we'll be just adding the context in terms of what are the request IDs being stored in the context. So on line number 14, if we emphasize, we have the logging.info, that is logging information request ID in current context. So what we have done is just replace the print statement with our logging initialization. And on line number 8, we have done a very basic configuration for our log, just for simplicity. And this is the same example where we had the print statements with multiple coroutines. The only difference is the logging. And the second thing is to actually emphasize on the explicit logging. So on line number 14, what we have done is we have explicitly mentioned what is the attribute from the context that we want to log. In this case, it is the request ID.get method that we have used, right? So imagine if we have a context which has lot many attributes. What we would be doing is, throughout our application code, we would be required to actually use those particular getter methods every time for every attribute. So it is slightly painful and more lines of code, more keystrokes. So, but in this case, what we can do is switch to the magic, that is the implicit contextual logging. This works more like injection of the context into the log lines. And if you see line number 9, what we have, logger.info handling request. We have nowhere actually mentioned what is the context that we want to log. It is smart enough to actually decipher what is the context that we want to log along, right? So the handling request is, we can say, like some event information that it is handling request, or maybe request is process. So different events would involve different kind of description. but as part of it, we could actually log different kind of information. How implicit logging is defined is, in logging module, there is a support for log filters, wherein we could actually add some filter to inject some information, or we can alter the logging lines, or we could actually decide whether a log line is being filtered or not. So in this case, on line number 10, if you see, it is a return true statement. What it indicates is, let all the log lines be logged. We are not taking any action based on the log message. We are allowing all the log lines to be passed. But on line number 9, we are doing the magic, which says record.message request ID is equal to request ID.get. So herein we are actually adding explicitly what is the attribute that we wanted to log. And this is the one place stop for adding all the context into the log. So if we have 10 such attributes, we could add that particular logic here and add all the attributes. This is more like an advanced configuration. If you remember, we had done a very basic configuration earlier, logging.basic config, and the usual scenario is to actually use a dictionary and support multiple filters or maybe different handlers. So in this particular dictionary configuration, we have just added those filters. When we run this particular code, we will automatically get the request ID. If we see, request ID is some UID that was generated randomly. Now, two things to notice is, one is, of course, we are seeing an object identifier here. We want to see something like a string, that maybe it is a string that signifies the request ID. And second thing is, when we had this single stop where we were adding all the attribute on line number 9, we could have different other attributes as well. So it could be very painful to add all other attributes. So let's make it more smart. So here is a more generic filter that we could create for request logging. So on line number 9 and 10, what we have done is, we have used the copy context method from the Contextual and iterated over it as a dictionary. So herein we are not explicitly adding that, okay, we are interested in request ID or request method or something. It is automatically taken care by itself. Although it is not production ready code, but it gives an inspiration where to incline our coding. So herein we could add some more logic and add some error check here to ensure that, okay, str method is available for that particular object. So different objects could require different handling. So that could be handled on this particular line. So in a way, of course, I think most of you agree that we want magic. Implicit logging is the way to go. Now let's wrap up with a quick use case of a fast API with the struct log. So someone mentioned log guru, and struct log is also a very popular library for logging. It is very flexible, gives you ability to add structured logs, and gives you an ability to add different kind of processors. Now, fast API, just a quick show of hands, how many of us have used fast API? Right. So fast API is, of course, very popular and one of the go-to framework for writing web services. In this particular simple example, we have a simple API endpoint that is a ping API. And the cool thing about fast API and other web frameworks like Flask is, they give an opportunity to add a middleware that intercepts request, whether it could be before the request is handled and or maybe after the request is handled. So in fast API world, what we can do is, we can just use a decorator app.middleware, and we could define a coroutine like log request. And in this case, we use the bind context varies and add all the attributes that we are interested in. So in this case, we have added request ID, request method, and so on. And eventually, after the request is handled on line number 18, eventually we could call the unbind context varies. Now, how do we configure struct log? This is more of an implementation detail, but what we have done is, we have used the context varies.merge context varies line on line number 3. What it does is, struct log is like, we had actually created our own contextual logging support earlier, but struct log is giving that opportunity from the framework itself. It is just exposing this particular processor. You use this processor and it will add everything from the context to the log lines. So that is one of the processes on line number 3. And on line number 4, we have just used the JSON renderer. So all the logs will be in the form of JSON structure. So that is particularly required for most of the modern applications. We have a central log frame, system where we are either we have all the logs registered, right? So that is more useful from querying the logs. Now, a sample run for this particular application would show up like this. We have an event like request received, and all the other metadata will be logged like request URL, request method, and all of this is happening kind of more like a magical way to do it. The only code that we wrote was the middleware code. So that is pretty much from my side about contextual logging. And thank you very much, everyone. You have been really good, and thank you for the organization. I'm working on something super cool around contextual logging. If you would want to collaborate, please scan the code, connect with me offline or through LinkedIn, and I would be happy to collaborate. Thank you very much.
I think we have 1 minute time to take questions. If someone has a question, can you pass for
In like a contextual login, do we have any mechanism where we can hide the like a secure data? For example, I don't want to have like expose the login credentials.
Right. So this is actually a super cool question. I am from a cybersecurity background, and what we do is there are two kinds of mechanism here. One is, of course, not logging something very sensitive, but there are two mechanisms. One is the proactive approach, one is a reactive approach. Let's say we actually log something super sensitive and it is actually logged and everyone is able to see it in a ELK or some other stack. So in that case, that is a reactive approach. It has already gone. But the proactive approach is we could actually, like we had the log filter, we could have some regular expressions which actually check for PAN cards, numbers, Aadhaar cards. So all of these are more of a policies we could define and add some of the common regular expressions. However, the cost is slightly more when it comes to slightly advanced patterns. For regular expressions, it is still doable. We could actually mask passwords, we could mask sensitive information which has certain structure to it. But a lot of information doesn't have a structure. And if we add some IO within the log filter, like we are making an API call to detect whether it is sensitive information, that will be an overkill for log lines because like the log lines should be unblocking and it should be super fast. So we want to cut down that particular use case for the reactive approach and keep some of the simple ones like pattern matching and those kind of things in the log filter.
Okay. Thank you.
Thank you.
Yeah, I think we can still take one last question.
One question around, like you mentioned that we can do contextual logging in a process, right? In like a single Python process. But how, or do you have some best practice recommendations in distributed systems? So across multiple processes, across multiple services.
Right. So one of the key aspects from the distributed systems is we usually what happens is there are either event-driven systems or there is at least one request that actually spawn everything down the line on the distributed systems, right? So that is kind of a source request that comes with a request ID. Either it is already having a request ID or we generate that request ID at the source. And that request ID needs to propagate entirely through the distributed systems. Now that is super, one thing is we want to actually create or accept that particular request ID at the source service, but at the same time, it could be propagated through headers. And whenever like we had a middleware here for our fast API, therein we were actually, in this code, we had a UUID generation for the request ID, but what we could do is extract that from the header information and add it to the logs. So that is kind of a trace ID request. But the key element is we need to be consistent across our all the services that we are interested in. That is the trace ID we could define. Some aspects, it is also used from consistency perspective, idempotency thing. So this could be used in that scenario. Thank you.
Yeah, all right.
Thank you very much.
Yeah, Tapan, I think